Well, by now you've unpacked your automatic thin sectioning machine and put it up on your laboratory bench. I'm going to take this opportunity right now to point out the different parts of the machine and their functions, get you a little more familiarized with the machine. Over on the left side of the machine we have the spindle assembly. It's comprised of the spindle drive motor and the spindle system that mounts the diamond grinding plate, the diamond blade, and if you've ordered it, the optional polishing plate. Also, this assembly has a mechanism for controlling the amount of material that the machine takes off of your thin sections. Over on the right side of the machine, we have the other main component of the machine. That's your vacuum chuck for holding the glass slides that your thin sections are mounted on, so that you can perform the different thin sectioning operations. This vacuum chuck is a very precise unit. It rotates like this, and it rotates under power. There's a drive system in back here. We'll show you more of that a little later, but this drive system supplies power to the chuck to provide the feeding for your thin sections. The whole area here is cooled with coolant from this coolant jet, which has a valve for controlling the amount of flow. And the coolant spray in this area is contained by the coolant shield, which has this fold-open coolant shield door. Really handy because it provides full access to the cutting area, but keeps the coolant confined to the area. Over on the right side of the machine is the control section. The control section houses the switching mechanisms which supply the automatic control of the machine, and a counter system that allows you to pre-select the number of machine cycles that you wish to use. Now, this whole basic setup is supported by a very rigid frame that supports the whole machine with adjustable machine mounts to give you a very accurate supporting of the machine. Also enclosed in the frame area is a pull-out coolant tray. This holds the built-in coolant and the coolant pump, the system that supplies the coolant for the coolant operation. Underneath all of this, we supply a bench tray to just catch any incidental drippings of coolant and so forth that you might have during the operation. I'm going to describe to you now the main control panel. This dial here is the main feed rate dial for controlling the feed rate of the vacuum chuck. This switch is used for main power. Notice the main power light turns on and off with that switch. This is the vacuum pump. Notice the vacuum pump is in operation. This switch is for the 2-speed spindle motor. This is low, this is off, this is high speed. This switch is the coolant pump. This switch is the spindle motor. And this switch is the chuck feed switch. Below the switch line here, you have a fuse holder. This is the main power fuse for the entire machine. This area of the machine is the control section. This housing contains the switching system, provides the switching control for the automatic functions of the machine. It has 2 toggle switches. The lower toggle switch in the front position is manual machine operation. The center position is off. The rear position is for automatic counter operation. Again, the front position is manual, the center position is off, the rear position is for counter operation. The top switch is rapid travel on the chuck, on in this position, off in that position. This is the counter unit that is part of the machine control system. The counter is a 2-digit counter, and you can control the number of machine cycles by changing these digits. Like for instance, it's 01, meaning 1 machine cycle, or it represents 1 grinding pass in the case of grinding. To set this up for 2 cycles, you dial in number 2, 3 cycles, so forth. This counter is also very useful in multiple machine cycles used in the polishing operation. On the right side of the machine, also there is a knurled collar. This advances and retards the vacuum chuck. Also, this collar, when you push it to the rear like that, disengages the gear train system so that the vacuum chuck is free to rotate. This is very handy in the case of repositioning the chuck, as this often becomes necessary. To re-engage the gear train, you just turn the knurled collar a little bit and it'll drop right in. An important part of the microtrim machine is this micrometer dial, which is used to control the amount of material that's taken off of the thin sections. It brings the diamond plate closer to or further away from the vacuum chuck. The indicator accurately reads any movement of the spindle. This dial indicator is accurate to 2 microns. Each division on this dial represents 2 microns, and it controls the amount of material that's taken off the thin sections. Here we're showing the amount of travel on the dial indicator rod, which by the way is only 20 thousandths of an inch. Another way to reference the dial indicator when calibrating it is to rotate the bezel. You notice the numbers on the dial plate are following the bezel when it's rotated. Once you have it set, lock it with the knob. For those of you that have the very latest Microtrim Phase 3 machine, you'll have the digital indicator. This digital indicator is coupled with the micrometer dial in the same way as the dial indicator, but the digital indicator is much more accurate. And to reference this indicator to 0, you only have to hit a button like that. The most important feature of this digital indicator is longer travel on the rod. Instead of 20 thousandths of an inch, you have 500 thousandths of an inch. The micrometer has a red reference dot on the dial. The dial is otherwise graduated in 6 micron increments. To set the reference dot, loosen the locking knob, rotate the dial so it lines up with the pointer on the micrometer, then relock the knob. To gain access to the coolant pump, merely remove the lid from the rear deck of the machine. Next, pull the slack out of the coolant hose, and at the same time, lift the pump out of the tray area. Feed the slack on the hose back into the machine, and you can lay the pump on the table next to the machine. This pump is fully submersible, and it is an efficient design that will give you many years of trouble-free use. Push the tray out from the back, and then you can pull it out from the front of the machine. This is really handy when you're changing coolant and doing general cleanup. There is a positioning spring on the left side of the tray. This spring urges the tray over to the right side of the machine frame where the drain tubes are. Push the tray right straight in and then close the flap door. To reposition the pump, pull the slack out of the coolant hose again and then fit the pump down through the access opening. Fit it down into to the tray so it sets nice and flat, and then feed the slack back into the machine. Replace the lid on the access. We're going to remove the gear guard here so we can clearly see the drive system for the vacuum chuck. However, when you make these adjustments, make sure you have the gear guard in place for safety considerations. The power system is comprised of the gear motor, a set of drive gears, a slip clutch mechanism, and a transmission shaft with a throwout collar. Here you can see we've been holding on to the throwout collar, and to increase the drive power, rotate the knurled collar on the front of the slip clutch counterclockwise as looking from the front of the machine. There you see we have driving power there. To decrease the amount of driving power, rotate the adjusting collar clockwise. And you can see there that the drive gear is rotating with no power to the chuck. Here we're increasing the drive power or torque by rotating this adjusting collar counterclockwise as looking from the front of the machine. There we've got it. Adjust it until it just begins to drive and then give it a half a turn more. When using the optional polishing equipment with the microtrim, plastic tubing is slipped over these 3 drain ports on the right side of the machine. It's essential to use tap water when doing the polishing operation. During normal operation of the microtrim, these ports must be closed by using the plugs as shown here. This micro switch opens the electrical system and shuts off the machine if the shield door is open. This plexiglass chip guard prevents rock chips from jamming the diamond plate or blade. The first thing that we do is add coolant to the coolant system. It can be done right from the top of the machine by adding coolant into the drain floor area. To gauge when the tray is full, you can look into the pump access area and observe the coolant tray and the level of the coolant. When the coolant is a half an inch from the top edge of the coolant tray, that is considered full. At this point, we'll set up the machine for grinding microscope slides. And the first step is to load the vacuum chuck with the glass slides. So we'll open the coolant shield door and start the vacuum pump. Now to start the slides, you place a corner of the slide, triangular corner, into the station area and then slide the glass into position. So that's station number 1. There's number 2. And the vacuum is holding the glass on the chuck. Number 3. Number 4. Number 5. 6. 7. When the last slide is placed on the vacuum chuck, it closes the vacuum system. Then this gauge will show an increase in vacuum level. This instrument is very handy to monitor vacuum levels and to indicate if there are any leaks present, such as broken slides. The next thing we'll do is to calibrate the dial indicator. It'll give us a reference point for taking the right amount of grind on these glass slides. To do this, we advance the vacuum chuck in back of the edge of the diamond plate so that half of the slide is behind the diamond plate. And then we spin the diamond plate by hand, while bringing the diamond plate in closer with the micrometer dial. We bring it in till we can just hear it touch the glass. Okay, at that point, we turn the anvil adjusting knob in toward the dial indicator. See, the indicator pointer is moving now. We're going up to 0, plus one turn, that's one full revolution, and a second full revolution to 0. That references the dial indicator to the unground surface of the glass slide. The calibration of the dial indicator is shown in greater detail here. We're rotating the diamond plate, bringing it closer to the glass slide with the micrometer. There we have touch off. Now we'll use the calibration screw to calibrate the indicator. There we have activation on the dial indicator pointer to 0, plus one revolution to 0, two revolutions to 0. The dial indicator is calibrated at that point. To verify the calibration, we back the diamond plate away and then come in again to 0, one turn to 0, two turns to 0, verifying we have calibration of the dial indicator. Here we're showing the calibration of the new digital indicator. Turn it on by pressing the on button. Then we can advance the diamond plate in toward the glass until we have touch off on the glass. And we can zero the indicator just by hitting this red button. Once the dial indicator has been calibrated, then we back the dial indicator away from the slide slightly and then bring the glass slide out from behind the diamond plate. And at this point we can set up the machine for grinding glass slides. Usually when grinding glass slides we take off 60 microns. So we'll move the micrometer. There's 10, 20, 30, 40, 50, 50 and a half. And then we use the lock lever. You usually get a slight bit of movement when you lock the lock lever to 60. That would be the setting for grinding your glass slides. At this point, we'll add the grinding jet to the machine. The jet is attached to the coolant chamber fitting and positioned like this, with this part of the jet horizontal. Then we snug up the fitting like so. For the grinding operations, we make the following switch settings. Main power switch on, it is on. Vacuum pump switch on, it also is on. We set the spindle speed to low, the coolant on, spindle on, feed on. We set the feed rate dial to number 4. We place the rapid travel switch in the forward or off position. We place the counter manual reset switch to the center position, which is off. This is the rear position, that's the center position, or off. That's the manual position to the forward. Center position off prior to grinding. To start the grinding cycle, first we set the counter for the number of grind passes. In this case, we'll use 0-2, meaning 2 grinding passes or 2 complete revolutions of the vacuum chuck. Next, we close the coolant shield door. Then we go to the manual reset counter switch We go forward to reset the counter and to the very rear to start the cycle. At this point, the red light on the counter is on, indicating the counting has started. As you can see, the glass slides are now being fed behind the diamond plate. Here we're seeing the subsequent slides being fed behind the top edge of the diamond plate. The top edge of the diamond plate, that portion is the working area of the diamond plate. Where the slides emerge at the bottom, there is clearance in that area, so there's no working in that area. All the work is done near the top, as you see here. The coolant flow should be turned up using the valve at the rear of the coolant shield, just enough to adequately flood the area with plenty of coolant. It's possible to overflood the area, but it's easy to gauge when you have the proper amount. Now this is the last slide on the chuck going behind the working area. These are slides emerging out from the bottom. And the entire vacuum chuck has just about completed its first revolution. That's the first grind on the slides. Now the first slide is approaching its second entry behind the diamond plate. Grinding the glass slides is a beneficial thing to do. It makes all of your slides more consistent in thickness, and the textured surface of the glass makes for a tighter bonding between the specimen material and the glass. When you're mounting with epoxy, actually the textured surface of the glass, if you look at it under a microscope, has very small, tiny craters. This allows a place for the epoxy to go to, and you can actually bond the surface of the glass closer to the surface of the specimen material by grinding your glass. Here the last slide on the chuck is going behind the working area, and the chuck is slowly approaching its original position, starting position. The first slide on the chuck is approaching the original starting position, and we'll have automatic shut-off here momentarily. There we have shut-off, and we're opening the coolant shield door here. And you can see a full complement of ground glass that's ready for mounting your thin sections. You can see the frosted appearance of the glass at this point. We set up for the sawing operation. We set the feed rate dial to 4, turn on the main power switch, the vacuum pump. We set the spindle speed at high speed, turn on the coolant, the spindle, and the feed switches. On the automatic control panel, we set the rapid travel switch to on, and we set the cycle switch to forward reset single cycle manual. To mount the diamond blade, we mount it on the spindle with the orientation mark facing out. Then we clamp it with the clamping disc. This disc has two bands, an outer band and an inner band. The inner band is relieved below the outer band a slight bit, so the outer band will tighten first, followed by the inner band. This clamping disc is placed with the bands toward the diamond plate. Then we follow with the spindle washer and the screw with the spacer. Remember, it's a left-hand screw. Then we tighten it with the Allen wrench. You can feel the outer band tighten first, continue through, and then you can feel a definite stopping when it hits the inner band. The sawing jet is now employed. It has two jets to direct a stream of water on each side of the blade, with the blade running between the two streams of water. This jet is added to the coolant chamber with the fitting. It's snugged up. Doesn't have to be real tight. Just snug it with the wrench and direct the jets in a direction, generally in a direction right below what the center of the spindle would be. We'll rotate the vacuum chuck to place this glass slide centered behind the edge of the blade. Now we'll set the blade by rotating the blade and bringing it up till it just contacts the glass slide. Then we'll back the blade off on the dial indicator 120 microns and lock the lock lever. We'll begin loading the mounted specimens into the chuck. We'll clear the number 1 station and load the first slide into number 1 station. And we progressively go along, loading each specimen into each subsequent station face. Number 7, or the last specimen, loaded into the chuck, and we check the mountings to make sure that the specimens are against the stops, these little button locator stops, so that none of the glass slides are out of position. If they are, it could cause a leakage in the vacuum system. Next, we'll close the coolant shield door. We'll start the cycle by pulling the cycle manual switch forward. Is now going through the number 1 specimen. Blade passes by the number 1 station face, it'll trip into rapid travel, giving a faster speed between cuts. travel again until the blade gets up close to the next specimen. Then it shuts down to the preset feed. We've got the first specimens coming out down at the bottom of the blade. Get a little more of a close-up of that. Plenty of coolant flow. And the chip parts off. Specimens are clearing the blade. Chuck is rotating around to its original starting position. And we'll have shut off here momentarily. And we have shut off. We'll open the coolant shield door. Remove the rock chips. It's important to remove these rock chips after each trimming each chuck load to keep the machine cleared of this excess material. We could remove these thin sections and load with more mounted specimens, and starting the cycle by closing the coolant shield door, but now for the sake of demonstration we'll go ahead and set up for grinding. We'll now remove the diamond blade with the Allen wrench. Remove the spindle screw and spacers. Set them aside here. And we'll change the coolant jets to the grinding jet. The grinding jet is threaded onto the coolant chamber. Just snug up the fitting, doesn't have to be very tight. And then we position the jet, the grinding jet, so this portion of the jet is horizontal. Next we'll mount the diamond plate. If you notice, the diamond plate has a little orientation mark on the face of the plate that goes toward the spindle. Also, the spindle flange has a notch on the edge of the spindle. We mount this diamond plate to the spindle and line up the two orientation marks so they're generally in line with each other. This ensures the truest running of the diamond plate. We place the clamp washer in position, the spindle washer. We do not use the spindle spacer. We it's not needed for mounting the diamond plate. Make sure that the diamond plate is far enough out from the chuck before, and that everything is free before clamping, doing the final tightening on the socket screw. There's the outer band on the spindle clamp washer, and the inner band where it does the final tightening. To reference our dial indicator, or to check our dial indicator, we'll replace the slide in number 1 station face, and we'll advance the chuck so that station face is halfway behind the diamond plate. And we'll rotate the diamond plate and bring the diamond plate closer to check our referencing on the dial indicator. There it's going to 0 plus 1 turn plus 2 turns, and it's just touching right at that point. We'll back this slide away to clear the specimens, replace it with the number 1 thin section. Now let's review touching off on the glass slide once again with a close-up of the indicator. Rotate the diamond plate, bring it in until it activates the pointer, and we go to 0 plus 1 turn plus 2 turns. And here we have the diamond plate just touching the glass slide. We'll start by grinding the number 1 thin section at about 90 microns on the dial. Then this thin section can be taken off the chuck and checked with a micrometer. Then we can advance the diamond plate in for say 50 microns, do another grind there and check it. We're going to work in progressively thinner to get a little more used to the machine. This is 30 microns. And usually your thin sections will finish up between 10 and 0 microns. On this dial, that'll give you approximately a 40 micron thin section. Begin the cycle by closing the coolant shield door. We'll put some illumination on here by turning on the machine lamp. We'll go to the control panel and set the spindle speed to the low speed for grinding. Then we'll set the rapid travel switch to off. Go to the predetermining counter and set it for 02, which is 2 machine cycles or 2 passes by the diamond plate. We'll pull the cycle reset switch forward for counter reset, and then we'll push it all the way back in order to get the start of the cycle. That initiates the grinding operation. Of course, with the rapid travel switched out, we don't have a high speed between the station faces during grinding. Rapid travel would alternate between high and low feed rates, and it would be detrimental to a good smooth ground surface. The grind actually starts at the top edge of the plate and continues on down to about the middle area of the plate. round thin sections emerging from the bottom of the grinding plate. We have more additional thin sections now being fed behind the plate. The coolant level should be high enough to thoroughly flood the area with coolant. We'll take a look at the bottom area of the chuck. We have thin sections emerging from the bottom area of the plate. And we have the last thin section for our first grind going behind the top edge of the plate. We're now on our second grind, thin sections emerging from the bottom of the plate. The reason we do two grinds is because the first grind takes off the major amount of the material, maybe on the order of even 100 microns. And the second pass takes off on the order of 2 to 3 microns and enhances the surface finish of the thin section. One more thin section to grind, the number 7. Take a look at these other thin sections here. To have automatic shut-off. And we have automatic shut-off. Open the coolant shield door. Looking fairly transparent now, except for these two here, which are silts, very dense siltstones, which will have to be down below 30 microns before they'll show any transparency. The thin sections on the chuck will finish up about 40 to 45 microns thick. And then you can take it through 2 stages of hand lapping on a glass plate with 600 and 1000 silicon carbide. For maintenance of the microtrim machine, refer to the cassette Maintenance Part 2